All right, everyone, we're going to go ahead and get started here. Thanks, everyone, for taking time out of their evening to come and join us here at MD Custom. My name is Nate Gentile. I am a regional consultant here in Wisconsin, cover some other areas as well at Microbiome Labs. So we're going to dive in. Today, the topic is all about gut health. It's something that we really focus on at Microbiome Labs. As we put here, we really believe a healthy gut equals a healthy you, right? It's, becoming more and more popular, right? Where, it's really becoming more or less a trend, right? Where all health really starts in the gut, right? So just a little bit about me, and we'll breeze through this. I went to Madison, studied biology, global health, worked in traditional medicine for quite some time before kind of making this transition to the space we're in here, right? More of this functional, integrative, holistic approach to medicine, which, I really believe is, the way to truly achieve health and wellness, right? Something that we should be after, right? So tonight, what are we really going to go over? We're going to do a little bit of a dive into the GI system and how there's really a lot more than simply just absorbing the food that we eat, right? A lot more going on. Then, of course, we are Microbiome Labs, so we're going to talk about the microbiome. What is it? What are some of the functions it plays in our health? Further, Western society, I love it. I love my cell phone. I love, we were just talking about AI, right? I love everything that comes out of it. But unfortunately, as we've really started to see, that's played kind of a detrimental role in our health, right, in many ways. And certainly when you look at not just gut health, but also the microbiome, there are certainly some detrimental effects, and we'll kind of talk about what that looks like. And then, of course, what we can do about it, right, from a lifestyle, diet, and, of course, some supplements that we can really do to try to curtail some of the damage that we do on a daily basis. Can you guys see the slides over there?
Yeah, I'm actually going to move.
Okay, yeah, I don't want to.
Oh, I will do that. Thank you.
And if I stand here, now do I block you? Yeah, no perfect spot. I'll try to move side to side here for you guys. There we go. Awesome. So the gastrointestinal system, just a little bit of background here, and I see some people nodding their heads. So do we have some healthcare practitioners? Yeah, okay, gotcha. So review for you guys, you probably talk about this better than I can. But, from an anatomy standpoint, we have 9 different organs. Many of them play roles in parts of our health other than GI health. I mean, I think that's within itself right there tells us how our GI, our gut health, plays a role in more facets than simply absorbing nutrients, absorbing the food we eat, right? When you break down the exact functions that are kind of listed per se in a textbook, we talk, digestion, absorption, right? Elimination and detoxification, right? So the gut-liver axis, we're going to talk a lot about these axes tonight. But in most of the toxins that are circulating through our body go through the liver, they're detoxified there. The majority of those are then dumped into our gastrointestinal tract, and eventually we hopefully poop them out, right? Unfortunately, and we'll get into this, sometimes when things go awry with the microbiome or the gut, some of those toxins can get pushed back into circulation, right? So elimination and detoxification. And then last but not least, we have the microbial balance and that barrier to the outside world. So we'll get into the microbiome, we'll get into detail on that, but this barrier to the outside world, and I know I have a slide coming up on this further down the road as well, is something I think that's really paramount and probably where a lot of our GI-related downstream health conditions, really come from in terms of we have this GI system that was really designed, and we'll look at this in greater depth, to absorb as much as we can, right? When we were evolving as humans, we needed as many nutrients as we get. We were deficient, right? So we have this single cell layer, and that can break, and unfortunately when that breaks down, that's when you get the influx of a lot of toxins, a lot of things that we're putting in willingly, but aren't designed to get fully into our body, right? And then a little fun fact, so this one is always fascinating, it always blows my mind. So if you were to take just your small intestine, right, so not even just the large intestine, just the small intestine, and you were to spread it all out, and we'll look at this, a little closer down so this makes a little more sense. If you were to spread it all out, it would actually cover an entire tennis court. That's within every single one of us, right? So that just goes to show how much surface area is there, designed, again, to absorb as much as possible, right? So roles of the GITX. So this is now kind of zooming in on that, right? So that barrier function, right? So what we're looking at here on the left side, we have what does a healthy gut look like? And then on the right side, what does probably the average American gut look like, right? So what we're looking at here is, if you can picture this, up on this, over in this area, this would be kind of that gut lumen. So like the tube where we're putting all the food and everything's kind of entering, right? Then we have these cells. These are all individual cells here. Again, they're designed to absorb as much as possible. So they have these little fingers that add surface area to, again, absorb as much as possible. And then you have your circulatory system here, right? So anything that's getting in there is getting absorbed and entering circulation and having this effect, right? Again, our whole system is designed to break down all these large food proteins, keep out the toxins, but eventually just allow your vitamins, your minerals, your micronutrients, right, your proteins, your macronutrients to be absorbed. Not huge, large food particles, not toxins, so on, right? Unfortunately, because of the toxins, because of a lot of the mean things, especially in Wisconsin, you know, we're notorious for our beer, our cheese, right? We have a gut that normally looks more like this, right? So as you can see here, you have the breakdown in between. Those are called tight junctions. Those break down, allowing stuff to come through. And then even sometimes further down the road, when things really start to get a little bit out of hand, you actually truly start to see the breakdown of the cells themselves, right? So now you just have these gaping kind of holes. That's what, you know, the technical term would be intestinal permeability. A lot of times what you hear in social media, or even, you know, a lot of clinicians at this point will call it leaky gut, right? So all in all, while it's designed, you know, we willingly put things in, but it's designed to be a barrier, right? We have the acidic environment of the stomach. We have these strong, tight junctions. We have a strong mucus layer here. But unfortunately, again, just due to, and we'll look at some of the reasons why, Western society just doesn't set us up for success with this. So then, the microbiome is another one of those functions, microbial balance. The microbiome, we're gonna dive in this, and, you know, don't worry, I have some videos of someone who's way smarter than me talking to, all right? So you're not just going to listen to me all night. But the microbiome is literally trillions of microbial cells. So we all have trillions of microbial cells. We literally have 10 times more microbial cells on us. We have microbiomes everywhere than we do human cells, right? It's kind of gross and weird to think about, just a fact of the matter. They support a lot of different roles, a lot of different functions in our body. But everyone's is a little bit different. And again, I love this picture because microbes, viruses, there's all these different things that are playing in symbiosis, hopefully. And they all play certain different roles. A lot of them really can benefit us. They can break foods down, break down some of those toxins. But they come in all different shapes and sizes, right? So this is a perfect kind of metaphor in what, if we have a healthy microbiome, if we have a healthy balance of good microbes, hopefully we have a microbiome that more or less would be operating like a beautiful rainforest, right? So you have different plants, different animals, they're all playing in symbiosis with each other, all supporting different levels of that food chain, right? Eubiosis, if you want to get technical again, is the technical term for a healthy microbiome. An overarching kind of principle with it is you have high amounts of what they now call keystone species. Keystone species are a lot of the bugs you would find in your probiotic formulas that you can take, versus high levels of what they would call pathogens, or the bad guys, which then, you know, can equal some bad things, right? Inflammation, the leaky gut, and so on, right? So we're hoping to build a beautiful rainforest, or a lot of times I'll hear about a beautiful garden, right, with all sorts of different vegetation and things working together, right? So we'll watch a little video here now. This is a mini little TED Talk that will kind of go into that with a little bit more detail. Oh, sorry. I don't pay for YouTube Premium, so I might have to watch a quick little ad here.
This is the story of the one.
This is not endorsed by Microbiome Labs.
Put everything on the line. But with a teammate like Ranger, she's confident.
Trillions of bacteria, viruses, and fungi live on or inside of us. and maintaining a good, balanced relationship with them is to our advantage. Together, they form the gut microbiome, a rich ecosystem that performs a variety of functions in our bodies. The bacteria in our guts can break down food the body can't digest, produce important nutrients, regulate the immune system, and protect against harmful germs. We don't yet have the blueprint for exactly which good bacteria a robust gut needs, but we do know that it's important for a healthy microbiome to have a variety of bacterial species. Many factors affect our microbiomes, including our environment, medications like antibiotics, and even whether we were delivered by C-section or not. Diet, too, is emerging as one of the leading influences on the health of our guts. And while we can't control all these factors, we can manipulate the balance of our microbes by paying attention to what we eat. Dietary fiber from foods like fruits, vegetables, nuts, legumes, and whole grains is the best fuel for gut bacteria. When bacteria digest fiber, they produce short-chain fatty acids that nourish the gut barrier, improve immune function, and can help prevent inflammation, which reduces the risk of cancer. And the more fiber you ingest, the more fiber-digesting bacteria colonize your gut. In a recent study, scientists exchanged the regular high-fiber diets of a group of rural South Africans with the high-fat, meat-heavy diets of a group of African Americans. After just 2 weeks on the high-fat, low-fiber, Western-style diet, the rural African group showed increased inflammation of the colon, as well as a decrease of butyrate. That's a short-chain fatty acid thought to lower risk of colon cancer. Meanwhile, the group that switched to a high-fiber, low-fat diet had the opposite result. So what goes wrong with our gut bacteria when we eat low-fiber processed foods? Lower fiber means less fuel for the gut bacteria, essentially starving them until they die off. This results in less diversity and hungry bacteria. In fact, some can even start to feed on the mucus lining. We also know that specific foods can affect gut bacteria. In one recent microbiome study, scientists found that fruits, vegetables, tea, coffee, red wine, and dark chocolate were correlated with increased bacterial diversity. These foods contain polyphenols, which are naturally occurring antioxidant compounds. On the other hand, foods high in dairy fat, like whole milk, and sugar-sweetened sodas were correlated with decreased diversity. How food is prepared also matters. Minimally processed, fresh foods generally have more fiber and provide better fuel. So lightly steamed, sautéed, or raw vegetables are typically more beneficial than fried dishes. There are also ways of preparing food that can actually introduce good bacteria, also known as probiotics, into your gut. Fermented foods are teeming with helpful probiotic bacteria, like lactobacillus and bifidobacteria. Originally used as a way of preserving foods before the invention of refrigeration, fermentation remains a traditional practice all over the world. Foods like kimchi, sauerkraut, tempeh, and kombucha provide variety and vitality to our diets. Yogurt is another fermented food that can introduce helpful bacteria into our guts. That doesn't necessarily mean that all yogurt is good for us, though. Brands with too much sugar and not enough bacteria may not actually help. These are just general guidelines. More research is needed before we fully understand exactly how any of these foods interact with our microbiomes. We see positive correlations, but the insides of our guts are difficult places to make direct observations. For instance, we don't currently know whether these foods are directly responsible for the changes in diversity, or if something more complicated is happening. While we're only beginning to explore the vast wilderness inside our guts, we already have a glimpse of how crucial our microbiomes are for digestive health. The great news is, we have the power to fire up the bacteria in our bellies. Fill up on fibers, fresh and fermented foods, and you can trust your gut to keep you going strong.
So, time to go home and eat a bunch of fiber now, right? A bunch of raw veggies. No, but all in all, I think that video did a really good job of kind of summarizing where things were at. And that video, I will say, is about 6 years old. We're going to bring in some other videos where we interview a true microbiome expert, and really they're from within the last year and kind of takes us up to date. But as they highlighted, I mean, some of the functions of a healthy microbiome are pretty numerous, right? So they mentioned a lot with digestive health, but another one that's really starting to gain in popularity is immune health, right? So experts estimate somewhere between 60 to 80% of our immune system is found right there in the gut, and it makes sense when you think about it, right? From a logical standpoint, as we're willingly putting things into our body every day. If we're willingly putting things in, there's going to be things that are bad that get in, right? So of course we need some of that immune system there, right? We talked about breaking down toxins. They talked about helping with diet, right? And then of course they talked about those short chain fatty acids, or post-biotics, which we're going to talk about, which really have been linked to a lot of health benefits. And that's where you can really start to assess, especially when it comes to supplements, if they're clinically studied, is this a supplement working on a microbiome that supports post-biotic production, which is really those beneficial compounds that hopefully your probiotics and your supplements are supporting, right? So we've kind of already hit on this, and the video did a good job of that too, but they're really starting to demonstrate now, we just talked about immune health, right? But the gut and the microbiome really plays a role in so many different facets of health. Something else that's really starting to pick up in a lot of steam is cardiovascular health and heart health, right? So DMAO is a compound that's been found to be produced in the microbiome, the gut microbiome, by individuals who eat a lot of red meat, right? And what has red meat been linked to? Cardiovascular disease, right? And this DMAO, they've actually found causes inflammation in blood vessels, right? So again, seeing this shift in the microbiome, seeing the compounds of the postbiotics, is the technical term again, that are being produced, can have these far-reaching effects throughout our body that go beyond even just gut health, right? So this next guy, and this is what we're going to see kind of moving forward here. Yes, he looks a little bit like a hippie, but I'm a huge fan of him. His name's Jason Harleck. So he's a naturopathic doctor who's still in practice. So he's always treating patients, seeing how things really come out, you know, once they're actually going on, as patients are taking things. But he also has a PhD, and he did his PhD, his dissertation on truly the effects of pro and prebiotics on the microbiome. So in terms of someone who's a true microbiome expert, he's someone that I really like to listen to and learn a lot from.
It's been an amazing journey to be part of in terms of the advances in technology that allowed us to actually see in much greater detail how much, one, the microbiome actually plays with every single disease state that we can think of, and two, what tools we can have access to from like dietary changes, lifestyle changes, prebiotics, herbs, and how they actually change the microbiota. Whereas you go back 20 years ago, the tools we had were so poor that we couldn't actually see that much. You could see little bits, but now we can see oh so much, and this is why this field is so exciting, because now we can actually start seeing these connections. And we've gone to that point where microbiome research has gone from that correlation, like, oh, this disease state is associated with this altered microbiome, to much more causation. And I think that's exciting too, that we develop models that we can actually show that the dysbiotic changes, the microbiome alterations, cause disease states rather than are just associated with or might be as a consequence of, which I think is also really exciting.
So we hit on something that's, I think, pretty crucial. And, you know, if you were to, you guys familiar with PubMed? Does that ring any bells? PubMed. So that's where it's basically the national database of all human health clinical studies, right? And you can go on there and you can type in certain terms, and they'll actually show you how many articles, how many studies have been published with that term included in them. And if you look at the microbiome over the last 20 years, it's grown by 500-fold, the amount of studies being published every year in terms of looking at microbiome. With that, the technology, like he mentioned, has really evolved, right, and the ways to assess it. So where it is very challenging, and this is done, but only on, you know, pretty sick individuals, is, you know, actually going into the colon and taking samples. But a lot of it is still done through our poop, right, our stool, right? And if you were to go back 20 years ago, simply what they would do is they'd take the poop, they'd put it on a plate, and they'd kind of see what grows and, you know, kind of make inferences, to, you know, inductions about that. nowadays, something that our company has actually been one of the leaders in developing, again, microbiome labs. We were the first company to come out with something called whole genome sequencing, where we take the poop, we take all the DNA out of that poop, and then we look at all of that DNA, where a lot of companies for a long time were just kind of taking certain parts of the DNA and, again, making inferences from it. But again, we do this whole genome shotgun sequencing that looks at all the DNA in the stool and then allows you to not only see who's there, who's not there, which is important, and you can do that under a microscope like they were doing for a long time, but also you can see what are these bugs capable of doing, right? So he hit on that too, in that some bugs are really good at actually helping with serotonin production. They say about 70% of serotonin is produced in the gut, right? So you can actually tell in our stool test how much GABA is being produced, right? Another neurotransmitter that has been linked in low amounts to anxiety and depression. High amounts is, healthier. Further levels of histamine, right? Histamine, we all think of with allergies, right? A lot of that allergy and a lot of that histamine can actually be produced in the gut too. So again, using this whole genome sequencing, using this latest technology, Key mentioned, we've really been able to kind of, versus saying, oh, these bugs are associated with people, that maybe they're overweight, and that now we can actually say, no, this bug actually produces compounds that shut down metabolism and create these further downstream effects, right? So again, the technology and where it's kind of going is just super exciting, super, super exciting.
It's been amazing.
So, kind of talked about it, how we're going to get to this, and these are just a couple examples, and I know this is kind of small for everyone, but we talked about the effects of Western society on our gut microbiome, and of course, like I said, I love my cell phone, I love technology, all that, but unfortunately, it's kind of had an effect on our health, and the microbiome has certainly not been left out of that, right? So here's just a few examples, and there's clinical studies are what's listed underneath there, just so you guys know I'm citing accurate stuff here, but of ways that have kind of had this detrimental effect, loss in that diversity of our microbiome that's kind of linked to those poor health outcomes. So this was hit in the video, cesarean sections, right? C-sections. When a baby is born, they're being exposed to so many different microbes, right? And I'll say this, my wife labored for 52 hours last year before our first baby was born, and eventually she had to go to a C-section, right? So again, C-sections are, sometimes needed. But with that being said, we've really worked hard on improving the microbiome of little Lucy and making sure that we kind of can hopefully get it back to a place where it should be. Herbicides and pesticides. This is one that I think it's becoming a little bit easier to avoid now. But still, herbicides and pesticides, a lot of them, for example, glyphosate. If anyone's ever heard of glyphosate, glyphosate's the number one we use in the U.S. It's outlawed in Europe, outlawed in a lot of other countries, but it was actually originally developed as an antibiotic, right? So it's approved as an antibiotic, was used as an antibiotic. We spray all of our food with it, and then we eat it, and it goes into our microbiome, and it does what it's supposed to do. It kills the bugs, right? What this study even talks about, take it a step further, is unfortunately it kills a lot of those healthy bugs, and a lot of the bad bugs that are linked to the inflammatory bowel, the IBS, the obesity. Those bugs are immune to it for, whatever reason. So again, herbicides, pesticides, trying to buy organic whenever you can. We'll come to another slide on that. Or grow it yourself at this point is probably really what you need to do more often. And then the use of antibiotics, that goes without saying. It's I think great to see how the use of antibiotics has, it went way up when I was a kid. If you had a little cough or something, antibiotic, right? Now that's kind of been curtailed a little bit because we're understanding the benefits of the microbiome, having a healthy microbiome. But still, obviously, antibiotics, again, necessary at some points, but the overprescription did do some damage for a long time. So another little video from Dr. Harleck
The
here.
ecosystem you have is unique, and it's something that's been passed down that family line to you from your ancestors, and you're a custodian of it. And it's really important that you nurture it, take care of it, and limit the damaging factors that happen to it. Now, there's obviously a time and place where antibiotics save lives and save limbs. We do that. However, we just know that they're really widely used for indications in which there's no evidence for them being efficacious for bronchitis and viral infections. And they're still used lots for that. Or there's a paper published a couple of years ago in a journal called Gut, which is my favorite gastroenterology journal. just for the name, essentially. They publish new papers too. But they found one course of antibiotics, 9 species went extinct. 9 species went extinct from a single course of antibiotics. You think, what's the impact of people who take 5 courses a year? And often I'm working with populations that were taking antibiotics for things they really didn't need. And they come to me like years later with all these health problems.
So again, nine species, just one course of antibiotics, right? So what does that equal? So remember the rainforest or that beautiful garden that we pictured earlier? But when you have an unhealthy microbiome, a good metaphor for it would be something like a desert, right? You have these certain mean-looking species, picture a cactus, right? Prickly, thorny, not fun to touch. They kind of take over, right? You have the loss of those keystone species, you get the high levels of pathogens, high levels of inflammation, and that is what has, of course, been linked to all sorts of, not just symptoms, but even disease states, right? So, I put the obvious ones. The GI stuff is where, again, we'll probably go right away. But some of the more, I think, not just intriguing, but scary in a way, too, some of the skin disorders, psychiatric conditions, or even further, what, frankly intrigues me a lot is the recent look into cognitive decline and how a lot of these bad species that contain a lot of compounds have really been shown that they can enter the bloodstream, go to the brain, and they find a lot of these compounds that they know are coming from the gut in high abundance around a lot of those inflammatory plaques that are found in Alzheimer's and, again, other cognitive decline. Parkinson's, another one, right? So we think of longevity and this world that, we're trying to live as long as possible. That's the kind of stuff where when I retire, I want to be, still thinking and remembering where I'm at and enjoying life, right? So all in all, just, again, that gut connection to all these different systems in the body really started to become abundantly clear. So again, if we were to zoom in, what does that look like? We kind of looked at a picture earlier, but this does another illustration and really does a good job of, again, illustrating how we have the gut lumen up there, the strong mucus layer that is there to be that's kind of innate defense, right? Similar to how we have mucus in our nose and ears and all, right? But then we have these cells that are designed to absorb as much, and then unfortunately, though, we get this breakdown, we get the influx of all these different compounds. We highlight LPS is a big one. That's one that's really been associated, again, with the cognitive decline in other instances. But then, of course, when the immune system has access to all that, that's when you get the high levels of inflammation and the downstream issues. So what can we do to combat this, right? Let's talk about some fun stuff now. Avoidance, of course. So we talked about it already, trying to buy organic when possible. There's a great organization out there. Is anyone familiar with the Environmental Working Group, EWG? Yeah. So they publish a lot of great up-to-date information on their website that talks about what fruits and vegetables in the exact season we're in right now. So if you were to go to the grocery store, which ones, maybe if you were to not buy organic, would have a little bit less of the herbicides and pesticides, if you're trying to watch, costs a little bit. Which ones you certainly do want to buy organic. Yeah. The dirty dozen is what they would call that, the ones that are really unhealthy. Frankly, a lot of times a good way to look at it is that the ones that don't have a peel have more herbicides and pesticides if you're eating the entire thing, right? And the ones that do have a peel have less. Frankly, too, that's where you'll see the difference in cost. You'll see like organic strawberries cost twice as much as non-organic strawberries. But again, it's, what are we weighing here, right? We'll talk about a microbiome-friendly diet, like certain, again, prebiotic fiber foods, but some of the maybe more tasty ones that you can do to really increase that microbiome diversity, get the good guys back. Exercise is actually linked, not over-exercising. I'm not saying to go run a marathon every week, but just light exercise, even 15 minutes of walking has actually been linked to more diverse microbiomes. Limiting stress, breathing exercise, meditation has been linked to healthier microbiomes. And then, of course, there are some great supplements, nutraceuticals that we can use to, again, really support the growth of a healthy microbiome. So prebiotics, probiotics, and postbiotics. Anyone feeling bold and want to take a stab at the difference between any of them? No? All right, everyone's shaking their head. Okay.